Hello, so today we are going to make a very simple pygame script. We're gonna load images. So let's save this file as load.py. You see in this folder we got another folder called player with a lot of images. So, first of all, let's copy the usual code to create a window, an empty window, with this run variable here. It's a boolean, contains a boolean value 0 or 1, and until this is 1 it will run the window. When it is 0, like when you quit the window, it will quit pygame. So we also need to have, as usual, we need to define the screen. Let me take it from here. The screen with the sides and the clock. Let's copy also some variables to center, to hold the value of the center of the screen, and the pygame in it too. Let's copy it in here, and now let's see if we get everything we need to get a window. Get to save this. So we get the window. Buffer screen is not defined. Okay, we got something that we don't need here, like this and this. Also this one, we can get rid of it. Also the time is not so important, but let's leave it. Okay, so we have our window. Now let's load one image. Let's go in here and let's load this image. Got strange names, let's say so, but let's choose this one that is work one, and we're gonna lose just one of these. So let's call this one PL1, like player one, and we got to do pygame dot, if I remember, image.load maybe, and this image is in player slash walk one dot png. Probably. Let's see if it works. Maybe it worked. Now we are loaded it, but we can see it. To see it, we get to put it on the screen with our method of the screen object that is split, and we put our image, that is, in this case it's a surface, because when you load an image, in the pygame will create a surface object. Like the screen is a surface object, but the screen is the whole window, and the player is another surface with an image, and it will be blitted on the main surface that is the screen. To blit it, we need also the X and Y position of the top left corner of the image, because the image, even if you don't see a square, a rectangle around it. It's like it has a rectangle. So let's place it at 0, 0, and let's see if it worked. There it is, our image. So now, if we want to see the rectangle, let's show this rectangle that is around the image to watch this rectangle visually. So let's call this play1rect equal play1.getRect to get this dimension of the let me show you what is this pl1rect, what contains this object. You see here, it's a rect object with 0, 0. There is a position up here. 614 is the width, and 564 is the height. We will probably say that the width is bigger than height, and you see, but it's not true because the width it's shorter than the height. But we see a PNG file with some transparent colors, that is the background, and we don't know how the background, let's say so, can be. It could stop here, but it could stop also here. Also the height could stop here, but could stop also here, where there is no color but a transparent color. So this means that even this is shorter in width than in height, it has to have some transparent like color, let's say so, that goes beyond what we see. So to see it, to make it visible, let's draw a rectangle that is of the same size of the image. To do this, we're gonna use the function pygame dot, because I like to do things visual, so that are more easy to comprehend to visual learners. So pygame.draw.rect. Okay, we have to say where we want to draw the rectangle. We want to draw it on the screen, and what else? I think the color maybe of the screen. There should be an option to don't fill inside the rectangle, but I don't remember it. How is it? But let's do it white. Let's color it with white, and then we will worry about the transparency of the inner sides of the rectangle another time. And then we have to put the coordinates of the rectangle. As we want it to be just like the image here, we will use that pl1rect. So let's see if it works. There it is. You see the rectangle. You don't see the player. Let's put this line of code after this so that we can see it. Now you see that this is the actual size of the image. You see it's double, almost a double of the width of the characters, and this is why there are some animation in this folder, because these images are meant to make an animation for this. And you see that when he falls and occupies, when he's on the floor, just the sides of his height. So to make this animation, we need to have an image that is as long as the height, practically. So that is why this image is almost a square. So when the player, the character is standing up, it will occupy half of the space when it's down, but the image is always the max width that it can be, because so you can, let's say, you can draw who made this animation can make it stay into the image of the same size. Otherwise it will have changed the size every time, and maybe it was not convenient. Maybe also when it jumps, it occupies a wider width, etc. Okay, so this choice of making the animation, that is why you can see that this rectangle is like this. This is not very good for game. If you want to use, you want to detect the collision of this player with other character, for example, because if you use this rectangle area as to look for the collision with other characters, we will have a collision even when we don't see that there is a collision, because there is all this empty space. So this needs to be solved, maybe without taking care of the actual width of the image, even if when he falls down he reaches here this part, so he will collide with other characters like in here. But this problem has to be solved with some R coding. But for the moment we have achieved our goal. Let's hide the rectangle. Let's get back to our image. So we got our image. Maybe what we can do, we could, well, that's all you get to do to show the image. Just load the image from the path where the image is, and then bleed it. What we could do, we could make something to make it easier. Well, as it's so it's just an image, it's simple, we don't need to make a class or something like that. But if we would make an animation, maybe it could be a good method to make a class. So let's make a class, because we don't know, we want to expand our code, and I love classes. So class, how we can call it, let's call it image. Okay, so let's also derive this image from the class sprite to inherit some functions, methods that could be useful. Sprite, and so this is a class of pygame, of course. Then let's do the dunder init method that makes everything starts. Let's do self here, and let's start also the super dunder init class to inherit all we had to inherit it from the super class. And let's, okay, this should go, and so now that we have done this, okay, maybe we can also avoid using self here, and what we can do is to also create a group. We can call sprites equal pygame.sprite, dot group. Then okay, now we have to pass the path of the image we want to load. Let's create a method called defLoad. I think I need to change my glasses. And here, let's do self image equals self load this, or self image equal pygame dot image dot load, and the path and the self path self path equal path. So now we can also we wanna sprites dot add. We wanna add the instances of this class to the group sprites. So now we don't have to do this anymore. We're gonna also do this with self rect equal. Let's do this here. Self image dot get rect. Okay, so now here we are, let's substitute this to image and the path to the image. So nothing very different, and there is even more code than before, but this will help us when we will make more complex things. So let's see if it's the same like before. Okay, we don't need this def. There's a typo here. So play one rect, it's not defined. Yes, we don't have this, we don't need this. Now screen bleed, player one argument, surface, not image. So this one says that this instance, it's an image and not a surface. Let's see why. So here our surface, we got it into, we could have done something like, okay, we will just do this and see if it works. Player one dot image. There's no attribute image. Okay, because we need to load the image before this, so we need to load it, and what we are going to do is to do self dot load here. It's no needed to do it like here. And okay, now we get our image, so everything is fine. And so we can say player one image, but we don't want to write remember player one image and everything. So one thing that we're gonna do is sprites, that is our group where we put our instance of the player, we put it in here in this list. Let's do update, let's run it, and still we don't see anything. So let's see sprites.draw on the screen. There it is. So now we have created this, but if we do another, player 2, and let's say instead of walk, we'll do jump, there should be a file called jump. You see here, we got two images, one onto another. But what if I wanted to put them in different path? We haven't a way to do it. So what we can do is so we got an image.rect. So let's say now that self x and self.y and self we like width and self.h like h, it equals self.rect. First of all, let's run the self-rect. You see here, okay. Let's also print self-image. Let's see, what is this? It's a surface. You see the dimension and the 32 colors. Okay. Now let's see what is rect.x. It's 0. Let's see what is also rect.y, .w, .h. You see 00600. Okay, so we just have suffix, so I don't need to do this. So I just need to do. Okay, let's see. Player one dot rect dot x equal 100. Let's see what happens. You see it? I change it. Let's see. 400. You see, it's gone here. So we have this way to change the size of the player one. We could also choose to put it in here, the size could be better. I don't know, we could do in both the ways, but we have to put a way to understand that these are the coordinates. So after we did this, we can do here self.rect.x equal, or here, yes, we must do it after we load, I think, and here, because otherwise, yes, we could do it another way. We could do self x equal x, self y equal y, and we could eventually go here. Let's delete this thing now that we have understood how the things works. Okay, let me see if I can do it. So self x equal self-rect x dot x equals self x, and self-rect y equals self y. So now we should change. So initially have you seen that we got 0 0, but we can give them the values where you want to the image to be, and so after we load the image, we change the position of the image like this, because it happens here. Then when we split on the screen with these two lines, our image, the position will be where we decided it to be. So require position argument x and y, of course, because now we got, and for this one we want to put 0 100. There we go. If we put this to, let's put a negative number. This is the jump animation. You see that now, as I give minus 100, it's out of the screen on the left. So we created our class image, and you have seen that now the class start to be useful now that we want to change the position, etc. It's easier, I think, to control the position. Okay, we can delete this. We don't need, because we just do it in the other way. See that nothing changes. Okay. Now we can also, if we want to just do the last thing for this time, I want to do a simple animation. We could also do one thing. We could use time here that increases. We can use this into with this. Okay, let's do plus time. See what happens. Okay, time is not defined, so time has not been taken as a global, I think, even if it should. To make a variable global, you can write into the function, to the method global. Let's see. Time is not defined. We could I don't get why it doesn't take. This is something that I am missing. Perhaps, yes, okay, now I get it. It's a stupid thing, but I get to put this one before this, to the, because otherwise this line of code start before time. Okay, time must be put before this one called this, because otherwise. Okay, so here it is, and you can see that nothing changes because I get to add plus time here. Okay, let me delete this global time. There's no reason to go. Okay, perfect. Why this happens? Because simply I got to create def update self and put it down here, otherwise it will just add time, just one time, 0, nothing will happen. Let's see if I'm right. Yes, there it is. You see some strange colors in the back of the screen. We can do this. You can do screen.fill 0 to, and of course we made an error that is not a real error, but it's an error for indentation. In case it happens to you and it says unindented, it means that here, for example, there is a tab as indentation. Here instead there are 4 spaces, as you can see, and have to be 1, 2, 3, 4, or everything must be or in spaces or in tab. Okay, now you can see that. You can see the animation because I have in every frame I fill with the black color the screen, and then I draw my sprite. And so we have seen how to do a little animation very simply using this time function. We cannot have control of that, but we can do it later. So so we simply, if we delete this was just for an example, we will see the images like this. Okay, that's all. Hope you enjoyed this video. We are going to add this class image to our project. It's called PyCartoon. I still haven't put the tutorials about this project. I will do it soon. I am preparing it, so I need to shorten the videos that otherwise could be too long, because if they are all like this one that you see, it's a little bit long. It will be very, very difficult to follow the tutorials. Okay, so see you next time and have fun. Until then, bye.